Piecewise functions, that's our topic today. Evaluating piecewise functions is just like evaluating functions that you are already familiar with. For example, let's calculate f of 2. However, with a piecewise function, you have two options. And what you have to do here is recognize which one of these options we need to plug into. In this case, our x is equal to 2. And so is it true that our x, which is 2, is less than 0? Well, no, that's not less than 0. That's greater than 0. So in this case, our x equals 2 actually fits into this category, this option here, x being greater than or equal to 0. So what we do is we're going to plug our 2 into this one. Okay, so plugging 2 in there, I get 2 minus 1, which gives me 1. So my f of 2 is equal to 1. What if I asked you for f of negative 1? Well, in this case, my x value is less than 0, so I should be plugging in to this option. So I take my negative 1, I plug it in here. Negative 1 squared is 1 plus 1 is 2. So that's how we evaluate piecewise functions. All right, maybe you want to try the following on your own. Try f of negative 2 and f of 5. All right, so you've paused the video and you're coming back now. You should have gotten for negative 2, plugging in here, will give you 4 plus 1 is 5. However, for 5, we're actually going to plug in here, and we get 4, because 5 minus 1 is 4. I don't think we need to do that extra practice. All right, our next step here is going to be to graph this. This is kind of tricky. What I like to do is graph both of them and then erase what doesn't fit the inequality. So first thing I'm going to do is I'm going to graph x squared plus 1. And if you need to graph a table for this, you can. I know it as a parabola that's been shifted up 1 vertically, but if that doesn't help you, let's just plug in negative 2, negative 1, 0, 1, 2, 3. Plugging into that, I get a 5. I'm plugging all into this. I get a minus 1 squared is 1 plus 1 is 2. This gives me a 1. This gives me 2. This gives me 5. And then that gives me 10. So graphing that, I get minus 2, 5. Okay, then I get minus 1, 2. 0, 1. Here we go. All right. So I get this and that. However, you might be freaking out right now being like, hey, Miss Sorensen, stop, stop, stop. This is only true for x is less than 0. So it's actually only true for this, and we're not even including that point. We're going to have an open circle there. So if x is less than 0, we're talking about you need to keep the graph from here to the left. So I'm going to erase this. And because I have a less than symbol and it's not the equal to symbol here, I'm actually going to have an open circle here. All right, so now we're done with that top equation. Now we need to go ahead and talk about the bottom one. So here, I'm going to graph this as a 1x minus 1, and we can think of the slope as 1 over 1. Of course, we graph our y-intercept first at minus 1, and then I go up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Okay, and I've got this line right here. And it's certainly true that it also it goes down there. Then you should say, hold up, Miss Sorensen, hold up, hold up. It should only be for x is greater than or equal to 0. So I should only be keeping the line to the right here. And so I'm erasing this part, and I certainly should have this point filled in because of the fact that I've got the equal to symbol here. All right, here's our next problem. We've got a 3x plus 2 for x is less than -2. So let's go ahead and graph that. So we're graphing our plus 2 right here, and then this is up 3, right 1. Up 3, right 1. Down 3, right 1. 1, 2, 3, right 1. And if you want, you can go ahead and draw your full line here, and then you can go ahead and say, hey, what should I keep and what should I not keep? So in this case, I want x is less than -2, so I would want this and over. So what I really want is, and it's hard to see because it's not much on the graph, but it would actually just end up being, so let's go down to here, it would just be from here over. That's it. And so I'm only keeping that part, and I'm also going to put an open circle here. Kind of doesn't look open, does it, with that green? Because it's a less than symbol right there. All right, now let's go ahead and graph minus x. Okay, so that's going to be -x plus 0, and you can think of this slope as a -1/1. So I will have a 0 here, and I'm going to go down 1, right 1, down 1, right 1, down 1, right 1, down 1, right 1. And then I know that this should only be kept from -2 to 1. So instead of maybe erasing everything, I'm just going to find where is it from -2 to 1. Well, it would actually just be from here to here. See, I'm -2 to 1. And then I have to figure out, do I want to have filled in circles or not? Well, here at less than or equal to -2, I know that I'm going to have a solid. But here at 1, I'm going to have an open circle there. All right, last thing we're going to do here is our x squared minus 2. And again, if you want, you can go ahead and create a table, or you can know this as a quadratic that goes down 2, or its vertex is actually going to end up being right here at -2. But let's try this table again. That is one of the easier ways to do it. So I'm going to have x is greater than or equal to 1. You could do the whole parabola, or you could literally just try plugging in the values that are true here. So let's try that this time. So plugging in 1, I get 1 minus 2 is -1. Plugging in 2, I get 2. Plugging in 3, I get 7. Plugging in 4, I get 14. So if you're like, hey, Ms. Sorensen, how the heck did you do that? I was just taking this x value and plugging it into here. All right, let's go ahead and graph that. So I have my point 1 minus 1, which is right here, right there. And then I have 2, 2. Okay, and then I have 3, 7. A little bit off the graph, and I think that's all we need to do here. So we basically have kind of a quadratic. It's really kind of a narrow quadratic, but that's all right. Now the question is, do we fill in the hole? Yes, we do, because we have greater than or equal to 1. So I'm going to go ahead and fill in this hole right here. All right, that's a good one. Here's the last one we're going to do. I highly recommend finding some graph paper, trying this on your own, and then checking your answers with me. Go ahead and pause the video and try it on your own. All right, you're back. So let's go ahead and graph x plus 4, and I'm going to use that color too because a lot of people say I'm fancy, and that's super true. So x plus 4 is here. I've got my slope of 1, which is up 1 over 1, up 1 over 1, up 1 over 1, etc. And I'm just going to choose x less than -4. So what I'm going to have here is, here's my x less than -4 would be from here over. So I'm going to have this. And now it is not an equal to symbol here, so I'm going to go ahead and have an open circle on -4. And then I can go ahead and erase all this. All right, now my 2x plus 5, that's going to be my red. So I'm going to graph 2x plus 5. There's my plus 5. This is up 2 over 1. 2 over 1. There we go, right there. And I have to remind myself that I want between -4 and 1. So that's between -4 and 1. It's quite a ways. Looks like it's from there to there. See how I'm from -4 to 1. And now let's go ahead and erase those points down below. And notice that these are both less than or equal to. They're that equal to, so I'm going to go ahead and put a solid point there. And our last is -x plus 3. So -x plus 3 starts at 3. And we're going to go down 1 over 1, down 1 over 1, down 1 over 1. And this looks like the problem wants us to be greater than 1. So it looks like we're going to have an open circle here, and greater than would be to this direction. And I can go ahead and erase my extra points. All right, folks, that's it for piecewise functions. Hope you enjoyed it.